I hold this up in front of the class and I say this, anybody know what this is? And of course, immediately everybody knows what it is. And then the next thing you ask the class is, do you know about this little button down here? And depending upon the age and experience of your class, they will know about the little button. And then you ask, well, what does the little button do? Okay? And at that stage, you will, I mean, if you're talking to this group, everyone knows what it does. But you're talking to a 9th grade group, and they haven't a clue. Okay? Ideally, you'll have someone who knows. Okay? And then say, well, explain to the rest of the class what it does. And so they proceed to explain the headlights and dimming the headlights and so forth like that. So in other words, they go through an understanding of what this thing does, okay? And then you say, how does it do it? Okay? And Ferd knows. And a lot of other
That's
people
the point.
Yeah.
I'm so old and I still, up until now, I didn't know what that button stands for.
So you all Okay, so you explain it. Now, I'm going to do it very briefly, only so you're filled in. In the article thing I published, I have lines and numbers and all this stuff. But this represents the mirror. This represents the back of the mirror that's silvered. And this represents the front of the mirror. And a lot of people don't realize that it's a prism-shaped piece of glass. I mean, the mirror is a prism-shaped piece of glass. Okay? And so when the light comes, oh yeah, and you also say, have you ever noticed that during the night you've been looking and you can see your reflection in a window? Yet during the day, you don't see the reflection in the window. And you say, well, is the reflection there? You know, ask that question. Okay, and the whole idea is to point out that whenever you have a difference of index for refraction, there always will be a reflection. In the daytime, it's bright from behind, and so you don't see the reflection, but it's still there. Okay? So in this particular case, this is glass, and this is silvered surface. And so let's just say, for top view, this is the top view. This is where the lights are coming in, and then striking the mirror like this, and then coming in and striking the eyes like that. It's important for you to understand that the headlights coming in, and then the light bouncing back into the person's eyes are coming in a different angle, because this particular diagram will become confusing if you don't realize that. So this represents the headlights coming in like this, and they strike the front surface. And they reflect off the front surface, but the reflection is fairly weak because it's bouncing off the front surface. Then the light continues on and strikes the mirror and reflects off the mirror almost as strong as in the first place, and then comes back. There's refraction there, but I'm ignoring that just to make the argument easier. And then this is the bright stuff coming back at an angle off in that direction into the person's eyes. And that's what you see ordinarily when you have the mirror adjusted. Okay? Now it turns out that someone comes behind at nighttime and shines bright lights into this. So you take and you move this little button. And when you move this little button, it moves this one down into position and moves this back one back off at an angle like this. Okay, so now this one is in the same plane that this one used to be. Okay? Now the bright light comes through and bounces off of this. They're bouncing off of that because this is glass. It has a much weaker reflection, so it goes back into the eyes. Okay, but meanwhile, this one that goes and hits that mirror there, and then bounces off of that mirror there, well, we'll say angle of incidence equals angle of reflection. Let's get this right. It goes up here. Okay? So the bright one goes up there, and there's refraction here, but the bright one, it goes off in that direction. This is the bright one, where this was the bright one before, and now this is the dim one. Okay? So the bright one goes off in the direction away from the driver's eyes. There's other things going on in there too, and in the article I explain the fact that this continues and another thing happens and all of that stuff too. Okay? So you have the basic idea. Fine. Now it's time for the demonstration. Okay? And here's the demonstration. Okay? So we have a laser here. We have a mirror here, okay, and then we have this mirror clamped so we can adjust it like this, okay. Now I'm hoping that I can line it up would be better on white. Let's see if I can get it to.
Better on someone's eyes.
Yeah, I can do that way and make it even much more realistic. Okay, so the first time I did this in a class, of course, I hadn't really tried it. And my hand kept getting in the way, and I said, what happened? Where did it go? Well, one of these little things right here, if you do it right. There. Okay, see the wall? Okay, this is the main reflection. Now, there's a little, you have to explain, but that's definitely dimmer. And that's definitely dimmer. Okay, so now keep your eye on that spot. Okay, keep your eye on that spot, because I'm going to change the mirror. Did you see how one of the dim ones moved into place? Okay, now I'll bring it back. Okay, so that's daytime, and that's nighttime. But one of the really brilliant things about the way this was designed is it makes no difference if the button is forward or back when you adjust it during the daytime. Because when you adjust it during the daytime, enough said. But the point is that one of the two spots will be out of alignment, but when you pull it forward or push it back, the light spot will come into your eye.